does have a section of proofs in it, so I want to refresh you on some of the properties. Okay, some of the properties that you use within a proof. So that's what we're going to do today. So the first four here are properties of equality. Okay, that's keeping your equation equal. So the first one is the addition property of equality. That says adding the same number to both sides of an equation. Okay, so you have an equation, you add the same number to both sides. So let's say I have 5x minus 4 is equal to 6x plus 3. Okay, say I want to solve this. Well, using the addition property of equality, I can add 4 to both sides of this equation. Okay, so that addition of 4 to both sides of your equation is the addition property of equality. It's keeping that equation equal by adding the same number to both sides. Okay, same thing with subtraction. Okay, subtraction property of equality, you're subtracting the same number from both sides of an equation. So this time, let's say we have 4x or 2x plus 4 is equal to 3x minus 2. Okay, so if I subtract 4 from the left-hand side of the equation, I have to subtract 4 on the right as well. Okay, so that subtraction of the same number from both sides is the subtraction property of equality. Okay, we also have a division property of equality, so that's dividing the same number from both sides of an equation. So let's say we have 5x equals 15. Okay, to get x by itself, I would divide both sides by 5. Okay, well, doing that step right there is called the division property of equality. Okay, when you do that step, it's the division property of equality. Okay, letter D is the multiplication property of equality. So again, same thing. You're multiplying the same number to both sides of the equation to keep it equal. So let's say I have 1/2 x is equal to 4. Well, to get x by itself, I would multiply both sides by 2. Okay, so that multiplication on both sides of your equation is called the multiplication property of equality. So all of these properties of equalities are the same. It just depends what operation you're performing. Okay, if you're adding something, it's the addition property of equality. If you're dividing, it's the division property of equality. Make sense? Yeah, you're still with me? All right. So our next property is substitution. Okay, so if x is equal to y, then x can be substituted in for y in any equation, and y can be substituted for x in any equation. So I'll do an example with numbers just so you kind of understand what's going on. So let's say x is equal to 7. Okay, and you have an equation of 3x minus 2. Okay, so you know both of these. Well, since I know x is equal to 7, I can replace this x value in this equation with 7. Okay, so then I would have 3 times 7 minus 2. So you're just replacing that value. Okay, so if you're replacing something, it is substitution. You're substituting that in. Okay, our next property is the reflexive property. This one we will use in this chapter with triangles. Okay, so remember when I said those two triangles shared the same side yesterday? Yeah? you have to actually state that it's equal to itself within a proof. To do that, you use the reflexive property. So for every real number x, x is equal to x. So that's when something equals itself. So if I have a triangle, I'll actually draw this here. So if I have this triangle, okay, and it's split into two separate triangles, right? Okay, at the vertex you have point B, and down here you have point A. Well, if I split that into two separate triangles, don't they share that side AB? Yeah? So then you would write this as AB is equal to AB, or congruent to. Okay? So that side is congruent to itself because that side is shared between the two triangles. Does that make sense? Yeah? So whenever something is equal to or congruent to itself, use the reflexive property. Okay, any questions on that first page? No? We're good? All right, so the next property you have here is the symmetric property. So for all real numbers x and y, if x is equal to y, then y is equal to x. So this comes in handy when you're doing algebraic equations and you end up with, say, 2 is equal to x, and we usually write it as x is equal to something, right, for our final answer. Okay, then we can flip it to x is equal to 2 because of the symmetric property. Okay, so you can flip those values. Okay, H is the transitive property. Okay, the transitive property states if A is equal to B and B is equal to C, then A is equal to C. So I'm going to do this example with some numbers just so it makes a little bit more sense. So let's say I have A equal to 7. Okay, and I also know that B is equal to 7. Well, since both of those variables equal the same number, don't they equal each other? Right? Okay, that's what the transitive property is saying. Since both of these variables are the same number, then they have to equal each other because their numbers are equal. Okay, so if something equals the same thing, they are then equal to each other. So our next one here is the midpoint theorem. Okay, midpoint theorem has to do with a midpoint. So our key word in this theorem is midpoint. Okay, so if M is the midpoint of segment AB, then you can say segment AM is congruent to segment MB. So drawing out a picture so you can see that. We have segment AB. Okay, and M is the midpoint. So that one has to be in the middle. Okay, M is the midpoint. Since M is the midpoint, I can say these two smaller sections are equal or congruent. Okay, that's where they're getting AM is congruent to MB. Okay, those two smaller sections are equal because you had that midpoint. Okay, next one is the definition of bisect. Okay, bisect is your key word here. That divides something into two congruent parts. Okay, usually we see this with angles. So if I have this angle here, okay, and there's a ray from that same vertex that cuts through the center of that angle. Okay, so that ray bisects that angle. If I say that ray bisects that angle, it splits it into two congruent angles, okay, that I'm going to label 1 and 2. Okay, so if you have this bisector and it's telling you the ray bisects the angle, then you would say, well, then I know angle 1 has to be congruent to angle 2. Okay, so those two angles have to be equal or congruent because it's bisecting it. Okay, the next one is supplement theorem. So that one states if two angles form a linear pair, then they are supplementary. Okay, your key word in this one is linear pair. So it has to form a linear pair. Now I'm going to draw out what a linear pair is if you forgot. Okay, a linear pair has to form a straight line. Okay, a linear pair has to form a straight line. And it is two angles that form that straight line. Okay, so you have two angles that form that linear pair, then they have to be supplementary. Okay, supplementary means they add to 180. So if I label my angles 1 and 2, I know I can take the measure of angle 1, that's what that M means, it means measure of angle, plus the measure of angle 2 to get 180. Okay, so you can add those two angles together to be 180 because they form that straight line. Okay, you can do that because of the supplement theorem. Okay, last one on this page is definition of congruent segments. Okay, when we use definition of congruent segments, you are switching from congruency to equal measures and back. So if you have equal measures, you can switch to congruency. So if I have segment AB congruent to segment CD, then I know AB equals CD. And again, this is the measure. Okay, it's talking about a specific measure of that segment. So if you know AB is 4, okay, then CD would have to be 4 because they were congruent. So if I have this segment AB and this segment CD, and I know they are congruent because they have that dash through them, you can switch that congruency to equal measures. So if I have A and B and I know segment AB is 4, well, since I know those two segments are congruent and I know AB is 4, what is CD? 4. So CD would also be 4. Okay, questions on this page? Okay, then on the next one, with definition of congruent angles, it's pretty similar to with your segments. Okay, you're switching between congruent angles and then equal angles. Okay, so if I have angle A is congruent to angle B. Okay, so here's angle A. Okay, and angle B. And I know those are congruent, so they have that arch dash in them, right? Those are congruent. Then I can switch it to equal measures. Okay, so since they're congruent, and if I know the measure of angle A is 40 degrees, well then the measure of angle B would also have to be 40 degrees because those were congruent angles. Okay, so if they're congruent, their measures are equal. Next one is definition of perpendicular lines. So that is two lines that meet at a right angle. Okay, so this one, you do need two lines. Okay, specifically they're talking about these two lines that meet at a right angle. Okay, so if I'm given, say, this line here, line L, and line M. Okay, two lines. And they say they meet at a right angle. They meet at 90 degrees. So you have that 90-degree angle then that's formed. Okay, that is the definition of perpendicular lines. Okay, we also have a definition of a right angle. Definition of a right angle is just an angle that has a measure of 90 degrees. Okay, so if I have a right angle, and I know this angle, called angle A, is a right angle, and they tell me it's a right angle, well then I know the measure of angle A would have to be 90 degrees. Now with complementary angles, you do need two angles. Okay? So this is two angles that add to 90. So we'll draw a picture of that. I'll make them adjacent, so next to each other. So here's a right angle. But I need two angles that add to that. So I'm going to split that into two angles. Okay, I'll label 1 and 2. Now since I know both of those together form that right angle, I can take the measure of angle 1 plus the measure of angle 2 to get 90. Okay, those are complementary because they both add to 90 degrees. Okay, next one is the definition of supplementary angles. Okay, those are two angles that add to 180. Now I'm not going to draw these ones adjacent. Okay, I'm not going to draw them making a straight line. And I'll tell you why in a second. So here I would have one angle. Okay, I'll label that angle A, and we'll say it's 100 degrees. Okay, here's my second angle. That's angle B. Label it 80 degrees. Okay, well, I have two angles. Now, if I add those two angles together, I do get 180. So if I take the measure of angle A plus the measure of angle B, I should get 180 degrees. Okay, those are supplementary. Now, I didn't draw them forming a straight line. Okay, definition of supplementary angles is different than the supplement theorem. Okay, we went over the supplement theorem on the previous page. Those ones have to form a straight line. Okay, they have to be a linear pair. To use the definition of supplementary angles, they do not have to form that straight line. Okay, it's just two angles that add to 180. Does that make sense? Okay, those two properties are different. Supplement theorem and definition of supplementary angles are different. Okay, next one here is the segment addition postulate. That states given 2 points A and C, a third point B lies on the line segment AC, if and only if the distances between the points satisfy the equation AB plus BC equals AC. Now that's a lot of words. Promise you it's not that difficult. So here I have a segment. Okay, segment AC. Point B lies on that line segment, somewhere between points A and C. Does not have to be in the middle. Okay, so point B lies between A and C. Well, all this is saying is I can take this smaller segment AB, okay, that smaller segment there, add on to it BC. Okay, so if I add those two smaller segments together, I should get this larger segment here, AC. So that's where they're getting this equation from. Okay, so AB plus BC is equal to AC. Okay, and we can highlight that equation. Okay, you have to take two smaller segments, add them together to get the larger in order to use the segment addition postulate.
I was like the most quiet class period.
You have one more page.
Yeah,
All right, then we have the angle addition postulate. So it's very similar to the segment addition postulate, just with angles. Okay, so that's two angles side by side with the same vertices. Create a new angle whose measure equals the sum of the two original angles. Okay, so you need this larger angle here. Okay, I'm going to say this vertex is B, and we have a point A and a point C on that angle. Well, now I need two angles that are next to each other. So I'm just going to split that angle, not in half, but just split the angle into two angles. And I'll label this top angle here angle 1, and this bottom angle here angle 2. Now with the angle addition postulate, I can take angle 1, add on to angle 2. Okay, so I can add these two smaller ones together to get this larger angle here. Okay, so add the measure of angle 1 plus the measure of angle 2 to get our larger angle of ABC. Okay, two smaller angles to get the larger. For the right angle theorem, this one has a lot involved in it. There's only one part that I need you to know. Okay, that one part is all right angles are congruent. Okay, all right angles are congruent to each other. So if you are given angle 1 and angle 2 are right angles. Okay, they tell you angle 1 and angle 2 are right angles. Well, then I can say that angle 1 has to be congruent to angle 2 because all right angles are congruent to each other. Okay, right? They're all 90 degrees. So since I was given they are right angles, I can then say that they are congruent to each other because of the right angle theorem. Okay, next one is the vertical angle theorem. Okay, that says all vertical angles are congruent. Okay, so if you have vertical angles, those two angles are congruent to each other. Now to refresh your memory of what a vertical angle is, vertical angles are created by two intersecting lines. Okay, so here are my two intersecting lines. Vertical angles are the ones across from each other. Okay, so if I have angle 1 and angle 2, I can say that angle 1 is congruent to angle 2 because of the vertical angle theorem, because they are vertical angles. Okay, so with the vertical angle theorem, this one is usually a freebie within a proof. Okay, you have to look at your picture in order to find that. Okay, so you have to look at your picture to see if there are any vertical angles created. And we'll go over more of that tomorrow. Okay, last ones have to do with parallel lines. Okay, this is from chapter 3. Last ones have to do with parallel lines. So, if your lines are parallel, then your different angles, so alternate interior angles, alternate exterior angles, and corresponding angles are congruent. Your consecutive interior angles then would be supplementary. Okay, so if I have parallel lines and a transversal that intersects those parallel lines. Okay, say I have angle 1 and angle 2 here. Since I know that these lines are parallel, I can say if those lines are parallel, that's what that symbol is, parallel, then angle 1 is congruent to angle 2. Okay, that is because they are alternate interior angles. Okay, so if I'm given that those lines are parallel, I can look for angles that would be congruent to each other, such as alternate interior angles. Okay, we also have the reverse of that. So now you're given that those angles are congruent or supplementary, then you can say those lines are parallel to each other. So again, we have our lines here with a transversal. Okay, again, I'll label 1 and 2. Now, if I know, or they give me, that those two angles are already congruent. Okay, they're labeled as congruent, right? So then if angle 1 is congruent to angle 2, then your lines are parallel. Okay, and we use the alternate interior angle converse. Okay, do you remember writing those converses at the beginning of the year? Yeah? Okay, converse means backward. Okay, since these are alternate interior angles, that's why I'm using that converse. If they were corresponding angles, I'd use corresponding angle converse. Okay, so if you're given the angles are congruent and you're proving lines parallel, that's when you use a converse. The other one, use if parallel, then those angles are congruent. Okay, so you have both ways there.